All right, so since we've done some of the easier stuff, let's move on to one of the more harder questions you might find for the answers you have to solve in this unit guide. Yeah, so let's get into it. So firstly, this is a combustion reaction, right? So, something reacts. So something reacts, right, with oxygen, and we get carbon dioxide and water as a product. Cool. So according to this, let's list out the reactants and list out the products here. So for reactants, we have carbon, and there's 5 carbon, as we can see there. There's 10 hydrogen and 2 oxygen, right? And for products, we have 1 carbon, 2 hydrogen, and 3 oxygen. So first of all, when I look at this table, the first thing I notice is that I have 5 carbon reactants, but only 1 carbon on the products. So let's fix that, and right away, let's add a 5 here in the product side, like so. So that means my new number for this becomes 5. So now I have 5 carbons, but remember, this affects only the carbon, but also affects the oxygen as well. So therefore, I have 10 oxygen here. But let's calculate that at the end, because I see another thing that you have to do straight away. Because I see that there's 10 hydrogen here, and there's only 2 hydrogen here. So let's add a 5 in front of this H here. So now 5 H2O. So that straight away I know this becomes 10. So let's do that. That becomes 10. So look at that, my carbons and my hydrogens are equalized. Now let's calculate the number of oxygen on the left and the right. So on the left we know there's 2 oxygen, and on the right we have 10, 15 oxygens. So let's do this, 15, cross that out, and I have 15 oxygens on the right side. All right, cool. So now we can see that there is only 2 oxygens on the left side. So to solve this equation, I can write basically 50/2 for the oxygens, right? Because doing so will give me 15 for my reactant side, right? This will give me 15. But something important about this is that I always want to use whole numbers, right? I always want to use whole numbers. I want to use whole numbers here in this case. So to do that, all I gotta do for whole numbers is I have to put 2 in front of everything so that this 2 gets canceled out. So I'll show you what I'm talking about. So if I add a 2 in front of, let's take this black. So if I add a 2 in front of here, right? Everything here gets doubled, right? So the carbons here become 10 carbon. The hydrogen becomes 20 hydrogens, all right? That means I have to double everything else as well. So these become 10, right? So 10, and this becomes 10. So therefore, you can cross this out. Again, this carbon from 5 on the right side becomes 10. So now it's still balanced. It's still perfectly balanced, right? And my hydrogen, as you know, it distributes here. It becomes 20. So still perfectly balanced. No problems at all. The next thing that we're going to be looking at is our oxygen. We're going to make sure that's balanced. The only thing we've got to worry about now, right? So right now, this gets canceled out, right? So here we can kind of understand that now for our oxygens, it goes from 15, right? It goes from 15 to, if we count properly, we can see there's 20 here because 10 times 2 is 20. And here we can see that there is 10. So now that there's 30 oxygens on the right-hand side. Now for our left-hand side, since that 2 is gone, all that's here now is just 15. So therefore, this becomes 30, as 15 times 2 is 30. So therefore, this is my balanced equation. My balanced equation becomes 2C5H10. Oops, H10. 5H10 plus 15O2. That creates 10CO2. And then you can another 10H2O. So that's basically my balance equation, and this is how you can balance a combustion reaction equation.